ahead and explain to the class what you did, please.
Okay, so I got 2 points, so then I got x1 and y1, x2 and y2 on each one of those. And then you have it down here, and you do y2 minus y1, and then x2 minus x1. So I have 2 minus 8. I got the y2 and y1, and then x2, and then x1. And then you subtract that, and I have -6, you subtract this, and I have -6. And then you divide those, and then I got 1.
Thank you. Rebecca, tell us, do you agree or disagree?
I agree on that part, but you didn't really write an equation that passes through the line.
Okay, yeah, so what did she do?
She found the slope.
She found the slope. Okay, so did she do that correctly?
Yes.
Yeah, she found the slope correctly. She just needs to keep working to write the equation. Okay, tell her where to go from here. After she finds the slope of 1, tell her what to do next.
I personally made a graph so that I can graph those 2 points. And
Okay, which method do you? Okay, so let's show her your method so that way if people see that they can see if they like doing it that way. And then Allison, when she's done, we're gonna do it your way also. All right, so make you a coordinate plane. Yep.
Like this one?
I make like 8 points on each one.
Okay. Okay, now once you made your coordinate plane, what did you do next?
I graphed those 2 points, so I went 6 over 6 up 8. And then I went 2, 0, and up 2.
So you like here,
Yeah.
And then what did you do?
I drew my line through it, and then once I got the, I wrote out my y equals 1x plus, and then I found where it went through the y-axis.
So where your graph goes through the y-axis? Okay, so where does your graph cut through the y-axis at? What number?
2.
2?
So it's y equals x, 1x plus 2, or just x plus 2.
Okay. Do y'all agree? Did y'all get that same equation, y equals 1x plus 2? Okay. All right, so the slope is 1, and if you graph the point 0, 2, and 6, 8, and draw your line, look at your graph there. Is it crossing through the y-axis at the 2? Yeah, so that would be correct. Y equals 1x plus 2, or just, and when you type it in the big ideas or into a test, you would just want to type in y equals x plus 2. All right, so that's one method you could use to do it. Allison, will you explain to her the method you used?
My line is y1 equals slope.
Okay, so write that equation down, y minus y1. And I'll just do it over to the left a little bit more because it's a kind of big equation. So y minus y1, okay, equals your slope, which is, what letter do we use for slope? M. And then parentheses.
X minus x. Okay.
All right, what did you plug in for your y1 and x1?
For my y1, I put 8, and then for my x1, I put 6. And then for my m, I just put x.
X wouldn't be your slope. What is your slope?
I mean 1. It would be 1x.
Yeah, so just put a 1 there. And then your parentheses, don't put the x yet. Don't put the x. Where you put the 1x, just put a 1. And then inside your parentheses, it would be x minus what?
6.
There you go. Okay. Now, what did you do?
I added I worked it out, and it was y minus a equals. Do I have to put the 1 by the x? X minus 6. Because I multiplied the 1 by the x and the 6. And then I added 18 sine. And then I got y equals x plus 2.
And there you go. So notice both methods, you get the same equation, y equals x plus 2. Or do you see where you may have made the mistake?
It's x2 instead of x1.
Oh, so like you use the 8 and the 0 instead of the 8 and the 6 or the 2 and the 0. Okay, yeah, perfect. If you want to leave that up there, that's fine. Also, something else I wanted to show you on this particular equation. See here where x is 0. Anytime you have x 0, that means this is going to be your y-intercept automatically. So I could tell right away that this was my y-intercept. So you didn't even really have to go through and do all of this. Once you have your slope and your y-intercept, you can write your equation y equals 1x plus 2. Okay. Only when that's a 0. Only when x is a 0 can you do that. That's like a shortcut. All right, so this is the type of thing, here, like I said, I wanted to show you both methods so that way, whenever you're doing your ELC, taking your ELC, if you can't remember this formula, you can always just plot the 2 points and draw your line and then figure out what your slope and your y-intercept are. And also, you're going to be given this formula, it just won't say point slope form. It'll just say Algebra 1 ELC, and then it'll have a bunch of formulas written on there on that page. Hopefully, you can look at it and say, oh, this is the formula for point slope. So like this will be on there, it just won't be titled, and you won't know to use it for which particular problems. You'll have to know that on your own. Okay? Because there are a bunch of formulas to remember in algebra. All right, once you get that copy down and completed, you can go ahead and put that away and go ahead and get out your notes for today. All right, so last week we started discussing polynomials. Polynomials are expressions, algebraic expressions, where you have a sum of terms. You can have 1 term, 2 terms, 3 terms, and a sum means you add them together. So like a term is like 2x squared, or 3x, or 7, or 2xy. Those are all terms. And then you can add those together, and that's polynomials. All right, so getting to our notes. So 7.1 day 2 is adding and subtracting polynomials. Adding and subtracting polynomials. All right, so whenever you're adding polynomials, what you want to do when adding polynomials, what you want to do is combine your like terms. Combine like terms. Okay? And like terms are terms that have the same variables and exponents. So like terms have the same variables and exponents. So if they do not have the same variable or the same exponent, you cannot add them together. For instance, last week, whenever we were talking about this, the question was asked, why couldn't I add those together? Well, it's like, because if you have something like a cube and then a sheet of paper, you couldn't say, I have 2 picture papers. You would have to say, I have 2 cubes and 2 pieces of paper. But if I have 2 cubes in my left hand and 1 cube in my right hand, I can say I have 3 cubes total because they're the same thing, okay? It's just like here. It's like apples and oranges, okay? All right, so it says find the sum. Okay, so what you're going to want to do whenever you're adding polynomials, you can, so that way it doesn't get confusing to you. Let me zoom in on that just so it's a little bit easier for you to see. You can rewrite this whole entire expression without the parentheses. So this is 2x to the third minus 5x squared plus x. That's one polynomial. Plus 2x squared plus x to the third minus 1. There's the second polynomial, and it wants me to add those two polynomials together. There's a couple different ways you can go about doing this. Okay. I'll show you one method here and then another method there, and then you can tell me which method to use on number 3. All right, so the first method I'm going to use is I'm going to align these two polynomials up vertically, just like how we used to do in elementary school. You know how you would write 23 plus 34, okay? And you used to do this. You would do 23 plus and then 34. You would have to line your ones up together and your tens and then your hundreds. And let's say this was 23 plus 134. The 1 would have to go out here in front because there's nothing to add it to. Okay, so that's what we're going to do. So you just want to make sure when you write it that you write it in standard form. And if there's any exponents missing, leave a space. So it's 2x to the third. So I'll write that one first, 2x to the third minus 5x squared. Well, it goes 3, 2, 1. So it actually goes in order. So I can just write it as 2x to the third minus 5x squared plus x. Okay. Now when I add this polynomial underneath it, I need to make sure that I line up the same exponents, like 2x, this is positive 2x squared. I would put it underneath the negative 5x squared, because see how this is a squared and that's a squared? I would have to put those together. So positive 2x squared would go under the negative 5x squared. And the positive x to the third would go underneath the 2x to the third. So positive x to the third. And then this negative 1, that's a constant. It doesn't match anything out here. It has a degree of 0. Well, here's 3, 2, 1. The degree of 0 wouldn't go underneath the x. It would go underneath here all by itself. And then to help you out, you can either leave those spaces blank or you can put in zeros in the missing spots. So for instance, here, this top number doesn't have a constant, so you can put plus 0 there. And here, this one doesn't have a linear term, it's missing an x, so you could add in a plus 0x just to take up space. You don't have to put those zeros in there, but you can if you want to make it so you don't think you're missing anything. And now you just go through and add everything together. So first you add 0 plus negative 1, which is negative 1. Then you add x plus 0x. Well, 1 plus 0 is 1, so that would just be 1x. And then you add negative 5x squared plus 2x squared. Well, negative 5 plus 2 is negative 3, so that's negative 3x squared. And that was a positive x, so I put a positive sign. And 2x to the third plus 1x to the third would be 3x to the third. Whenever you're adding terms together, like terms, you add the coefficients, but leave the variable and the exponent the same. So if I have 2 blocks and I add another block, that makes 3 blocks. If I have negative 5 pieces of paper and I add 2 to it, then that leaves me with negative 3 pieces of paper. So this would be my final answer, 3x to the third minus 3x squared plus x minus 1. Okay, that's one method. The other method is to rewrite this without any parentheses and then go through and add your like terms together. So for instance, you would do 3x squared plus x minus 6 plus x squared plus 4x plus 10. So I just went through and wrote it without any parentheses. Then what you're going to want to do is go through and look for the biggest exponent first. So my biggest exponent is squared, x squared. So I'm going to highlight all the terms that have an x squared. So I would highlight the 3x squared and the positive x squared. And I would add those together. Well, if I have 3 and I add one more, 3 plus 1 is 4, so that would be 4x squared. Now the next number below 2 is 1. So now I'm going to look for all the terms that have an exponent of 1. Well, that would be the positive x and the positive 4x. Okay, this is 1 plus 4. So I have an x and then I add 4 more x's. That makes 5 x's and it's positive. So that would be positive 5x. 2, 1, 0. The next one would be a degree of 0, which is a constant. So now I add all my constants together. Well, that would be negative 6 and positive 10. So I would add together negative 6 plus 10. Well, negative 6 plus 10 is positive 4, so I put positive 4. So I would have 4x squared plus 5x plus 4.
I like that one. Yeah, I like that one better.
Okay, so either method is fine. Whichever method you prefer, use it. I'm okay either way. Now, if you don't have highlighters to use, another way that I show which ones are like terms, like I would put a box around 3x squared and positive x squared, showing that they're like terms. And then like I would circle positive x and positive 4x. You know, I would use a different shape. And then the last ones, I would maybe put a heart around it. Just something showing that they're the like terms. Like, you know, those both have a box. Those both have a circle. These both have a heart. Now, if there's nothing to combine it with, you just leave it alone and just bring it down. Okay. So hopefully this next one has that.
It does.
Okay. All right. So number 3. So is everybody okay if I use this method here where we just combine the like terms?
Yes.
Okay. Number 3, x squared minus x minus 2 plus 7x squared minus x. So first thing I'm going to do is just rewrite it without the parentheses. So x squared minus x minus 2 plus 7x squared minus x. Okay. So find the biggest exponent. So what's my biggest exponent there?
Squared.
Yeah, the squared, the 2. So highlight every term that has a 2. And don't forget the sign in front of it. So this is positive x squared and positive 7x squared. Okay. So what's x squared plus 7x squared? 8x squared. Perfect. Now what would be my next degree going down from 2? Well, my next degree down from 2 would be 1. And which terms have a 1 as the exponent? Yeah, the negative x and the negative x. What's negative x plus negative x? Yeah, negative 2. This would be negative 1 plus negative 1. Negative 1 plus negative 1 is negative 2, so that would be negative 2x. And then the last one would be my constant. And here's a blue. And so my constant, I just have one of those, which is negative 2. So all you got to do is bring down your negative 2. That's it. All you do is go through and combine your like terms.
Will we have the mark tonight?
If you don't finish it in class, you will. Okay. All right, so that's adding polynomials. Now let's look at subtracting polynomials. When subtracting polynomials, step 1, distribute the negative. Distribute the negative to the back polynomial. So distribute the negative to the back polynomial. And then your second step is to combine all of the like terms, just like we did before. So distribute the negative to the back polynomial and then combine all of your like terms, just like you did with adding. Now, if you recall, all the way back to 7th grade, when you were subtracting and you were learning about negatives, you did this thing called keep, change, change. Let's say, let me get another sticky note. Let's say you had to do -2 minus 7. Okay, well, back in elementary school, they showed us keep, change, change. Keep the first number, the sign it is, change your subtraction to addition, and then change the sign of the back number. So that's keep, change, change. So now instead of -2 minus 7, it's -2 plus -7, and then you use the same rules you use for adding integers. Okay, that's a lesson all the way back from 7th grade. Same thing goes for polynomials. The first thing you're going to do, see this negative here? You're going to distribute this negative to every single term in this polynomial. And really what you're doing when you're distributing a negative, you're going to keep the first polynomial the same, change that to addition, and then change all these signs. So the first polynomial stays like it is, 4n squared plus 5. So we write that without the parentheses, 4n squared plus 5. This minus gets changed to a plus, and then you change every sign here. So this -2n squared becomes a positive 2n squared, and I've already got my positive sign, so I just leave it as 2n squared. That becomes -2n, and that becomes positive 4.
Do we just add the rest of it together?
Well, we're getting there. Right now, the first thing you do is distribute the negative. Okay, so you change the -2n squared to a positive 2n squared. The positive 2n becomes a -2n, and the -4 becomes a positive 4. So you just go through and change all of these signs. Now you're going to do the exact same thing that you did at the top. So now we combine our like terms. So look for the biggest exponent, which is a 2. So 4n squared and positive 2n squared are your like terms. So you add those together, just like we did before. What's 4n squared plus 2n squared?
6n squared.
Perfect. Now you look for your linear term, and it just has 1 there, which is -2n. So all we do is just bring that down, -2n. And then we do our constants, which is positive 5 and positive 4. What's positive 5 plus positive 4? Positive 9. And there you go. So you're going all the way, pretty much you're going back to 7th grade and using keep, change, change on these, anytime it's subtracting. Now that you know how to do this, don't get back confused to when you were up here and adding. When you're adding, you don't do that. Only when you're subtracting. Okay? All right, so let's do it again together. 4x squared minus 3x plus 5. You keep this one the same. Okay? And you distribute the negative to everything inside here. Okay? So right now inside the parenthesis, this is a positive 3x squared. It becomes a negative 3x squared. You change the sign, it becomes a negative 3x squared. This negative x becomes a positive x, and this -8 becomes a positive 8. Now that you've distributed the negative, now you combine your like terms. Okay, so I see the biggest exponent is this 2 and this 2. So I've got to add 4x squared and -3x squared. What's 4x squared minus 3x squared? Yeah, 1x squared, and we just write that as x squared. All right, the next one is as my exponent of 1, so this one and this one. So that's negative 3x plus positive x. What's negative 3x plus positive x? Negative 2x, perfect, because that's negative 3 plus 1, which is negative 2. And now you do your constants. Positive 5 and positive 8. What's positive 5 and plus positive 8?
13.
And there you go. Ooh, quick question. What type of polynomial would this be? It's a trinomial, and what would the degree be? I'm sorry, I heard somebody say it. What is it?
Quadratic?
Quadratic, yeah, it has a degree of 2, so it's quadratic. Yes, ma'am.
Say you were to get like a 0, like whenever you're adding two of the like terms together, would you put plus 0 or would you just not put anything?
Not put anything. Yep, yeah, you just leave it blank.
This chapter seems to be really easy.
It is until you start combining everything together. Like if you get, people do really good when we're adding and subtracting. People do really good when we're multiplying. But whenever we combine them together and you have to do an assignment where you're adding, subtracting, and multiplying, people get the rules confused.
Do we do any of that today?
No, we're just adding and subtracting today.
Okay.
We will start multiplying after the quiz on Wednesday. All right, number 6. Remember, the first one stays the same. You keep it. So negative k plus 5. You do keep, change, so we distribute the negative. So this positive 3k squared becomes a what? It becomes a negative 3k squared. And what about that negative 6? What does it become? Positive 6. Perfect. Now combine your like terms. Which term would be going first?
Negative 3k.
Perfect. Negative 3k to the second power, or negative 3k squared. Is there anything I need to combine it with? Nope. So I leave it as negative 3k squared. Now, what would be my next term? Is there anything I need to combine it with? Nope. So it just stays as negative k. And what are my constant terms? And what's that going to equal? There you go. All right, are we doing okay so far? Okay. All right, I did one more on subtracting just because, subtracting has one more step than adding. Subtracting and adding are pretty much the exact same thing. It's just subtracting has one extra step in it. But really, if you're rewriting them anyway, it's really the same. It's just whenever you're first rewriting it, you just have to remember to change the sign in all the back ones whenever you're subtracting. All right, so next one, keep the first polynomial the same. So p squared plus p plus 3. And then we distribute the negative. Okay, so what happens to this negative 4p squared? Yeah, it becomes a positive 4p squared. What happens to the negative p?
Positive.
And the positive 3?
Negative.
Okay. Now, which term will go in first? Which one would go in front?
P squared and 4p squared.
Yeah, the p squared and the 4p squared. Make sure you include that positive sign. What's p squared plus positive 4p squared? Okay, which term would go next? Positive p and positive p. What's positive p plus positive p? And then which term goes last? Yeah, the constant. So positive 3 and negative 3. What's positive 3 plus negative 3? 0. And that's pretty much that canceling out. So we just leave it. We don't put a plus 0. So this would be our answer. 5p squared plus 2p. All right. Turn it over. All right. Before we turn it over to the back, what questions do you have for me? Okay. All right. Now let's turn it over to the back. It says, a penny is thrown straight down from a height of 200 feet. So it's showing you right here. This person's throwing a penny down from 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. The polynomials represent the heights and feet of the objects after t seconds. So what this polynomial here represents is, if I asked you to find me the height of the penny after 3 seconds, you could plug in 3 for t and then work this out, and it'll give you the exact height of the polynomial after you dropped it, 3 seconds after you dropped it. This expression will give you the height of the paintbrush after you drop it, and t is the second. So like if I said, what's the height of the paintbrush after 3 seconds? You would plug in 3 for t, and you can find the height of the paintbrush. So let me show you. And if you would please do this the same time that I'm doing it, so you know how to enter it in your calculator. Okay, so I want to find the height of the penny 3 seconds after it was thrown. So you would type in negative 16. So negative 16, make sure you're using the negative button. That's at the bottom here. Negative 16. And then times t squared, and t is 3 seconds. So you would do 3 to the power of 2. If you're doing squared, you can just hit this button that says x squared, and it automatically puts it to the power of 2. Or you can do this button here, the caret that's up above the division symbol. It looks like the top of a triangle. That means to the power of, and then you type in 2, and then hit the arrow to get out of it. Or if it's squared, you can just type that x squared, and it automatically squares it. And then minus 40 times t, so it'd be 40 times 3 plus 200. And then hit enter. Negative 64. So it's saying it will be at negative 64 feet after 3 seconds. So that means it's already hit the ground.
I did not get that.
So make sure whenever you type it in, make sure you do negative 16. So the negative button is down here at the bottom. Right here, here's the negative. So negative 16 times 3 to the power of 2. So 3 squared. Your 2 should be an exponent. And then you might have to get out of the exponent. You might have to hit this arrow button to get out of the exponent. Minus 40 times 3. So 40 times 3 plus 200.
That's the same exact thing I typed up here. I got 2 different answers. Look, it's really the same thing. And it gave me 2 different answers. And the second time you typed it, you didn't get the right one. But I typed the same exact one right here. Oh, never mind. I didn't type it the same way. It looks the same, but on the minus 40, I put negative 40. So
Oh, yes, that would be the reason why. So they would have times it by negative 40. All right, so what this means is it hit the ground and went 64 feet below the ground, which that's not really going to happen. So let's do the paintbrush 1 second after you drop it. So here's the paintbrush's equation. So you do negative 16 times 1 squared plus 100. 84 feet. So after 1 second, this paintbrush is at 84 feet. It started at 100 feet, and after 1 second, it dropped to 84 feet. Okay. All right, so part A says, write a polynomial that represents the distance between the penny and the paintbrush after 10 seconds between. So they want to know how much distance is between the penny and the paintbrush. How do you think we're gonna do that? Yeah, you would do subtraction. So you would take this polynomial of the penny and subtract the polynomial of the paintbrush. So you would do negative 16t squared minus 40t plus 200 minus, do your parenthesis, negative 16t squared plus 100. Okay. Now you would do exactly what we did on the front page with subtraction. And guys, I hope you can see that on the screen because it's real blurry to me, but I know I'm pretty much blind. Okay. When you're subtracting, remember the first one stays the same. So negative 16t squared minus 40t plus 200. And then we distribute the negative. So that negative 16 squared becomes a positive 16t squared. Positive 100 becomes minus 100. And then you combine your like terms. What happens here with the negative 16t squared and the positive 16t squared? It cancels. And then we have the negative 40t. Do I have anything to combine that with?
No.
Nope. So I just leave it as negative 40t. And then we add 200 and negative 100. What's that? 100. So this represents the distance between them after t seconds. So part B says, what is the distance between the penny and the paintbrush after 2 seconds? How am I going to find that out? What am I going to do? Ooh, good job using the word substitute. So 2, we're going to substitute it in for t. So do negative 40 times 2 plus 100.
40. Negative 80. 20.
I got 20 on mine. Negative 40 times 2 would be negative 80, and negative 80 plus 100 would be 20. Oh, the negative 40 times 2, yeah, that part's negative 80, and then add 100 would give you 20. So it would be 20, does it say it's in feet? Yes, it says in feet. So there would be a 20 feet difference between the two after 2 seconds. All right, what questions do you have for me on adding and subtracting polynomials? All right, so for your homework assignment, it is on Big Ideas Math, 7.1 practice. It has some classifying and it also has adding and subtracting. I can't remember exactly how many times I think I put on there that you could have checked your answer once. Make sure on the adding and subtracting, make sure you show your work on a separate piece of paper, and this will be due when you come to class tomorrow. Okay. What questions do you have before you put your stuff up? All right, you can go ahead, put up your calculators, get your phones. Don't forget your homework assignment. Do it at the beginning of class tomorrow.